So I'd like to do a quick tutorial on polar coordinates. Polar coordinates are not that difficult. You're still graphing position of a point on a plane, just like we have done in the past with rectangular coordinates. We'll talk about why they're called rectangular coordinates briefly. If you think of your traditional graph on a Cartesian plane, and the way we would graph a coordinate is we would list the x-coordinate and the y-coordinate, and we would go across the x-axis to the x-coordinate. We would go up the y-axis for the y-coordinate, and where those two would form a rectangle is where that coordinate would be located. Related to that, for polar coordinates, what we have is a line that goes from the origin to that coordinate, and our coordinate will consist of our r, or radius, and theta, which is our angle from 0 to that line r. So xy would have a polar coordinate of r theta. So let's take an example. We're going to convert the rectangular coordinate negative 2 square root of 3, 2 square root of 3, to a polar coordinate. To me, it's probably the easiest to kind of look at a sketch and understand what's going on in terms of these coordinates. So if I were to sketch this out, just similar to the sketch I had earlier, the coordinate negative 2 square root of 3, 2 square root of 3 would be somewhere here in the second quadrant, where 2 square root of 3 and negative 2 square root of 3 would coincide with this point. If we were to look at the angle formed with the positive x-axis there, so we're now looking for this angle, and we need to know what this distance is. Well, considering our x and y values, the distance here and the distance here are going to be 2 square root of 3, 2 square root of 3. So our r value is going to be r squared equals a squared plus b squared, because it's a right triangle. So 2 square root of 3 squared plus 2 square root of 3 squared, and that gives us r squared equals 2 squared is 4, square root of 3 squared is 3, 4 times 3 is 12, 12 plus 12, which is 24, and when I square root both sides, r equals the square root of 24, or simplified, that's going to be 2 square root 6. I'm sorry. So our r value is 2 square root 6, so our polar coordinate will have an r value, 2 square root 6, and now we have to figure out how to find the angle here. Well, if you remember back to your trigonometry of the unit circle, this would be our reference angle, correct? So to find our reference angle, we could use tangent, cotangent, or cosine. In this case, since the two values they gave you were the opposite and adjacent side, let's just use tangent for this. So the angle theta, the tangent of theta, is equal to 2 square root of 3 over 2 square root of 3, which is 1. Now we know since we are in the second quadrant, the tangent is going to be negative, which it kind of works because if we had really used the x and y coordinates as given, the x value would have been negative anyway, and we would have had -1. And the coordinates now are going to, so now we need to find the arctangent of -1. Well, since we're in the second quadrant, we should know that that's a 45-degree angle. So this would be 90 plus 45, 135 degrees. Or if we were doing it in radians, 2 square root 6, 3 pi over 4 radians. And that would be our polar coordinate that corresponds to the coordinate -2 square root of 3, 2 square root of 3.